I'm Anil Kumar, and in this video we'll explore what is the limit of the function as x approaches infinity. The question here is find the following limits or state that the limits does not exist for two of these functions, right? The first one here is when x approaches infinity, 2 to the power of 2x minus 2 to the power of x divided by 2 to the power of x minus 1. The second one is limit x approaches infinity for 2 over x minus 1 minus 3. So I'd like you to pause the video, answer these questions, and then look into my citation. Now this is a very important question from test point of view. I'd like you to note the strategy here. So the strategy here is factoring. 2 to the power of 2x minus 2 to the power of x. What is common? 2 to the power of x is common, right? So we could write this as, when I write 2 to the power of x common, so if I divide 2 to the power of x, 2x minus that, what do I get? I get 2 to the power of x, right? Minus 1. That is what I get in the numerator, and the denominator is 2 to the power of x minus 1. Do you get the idea, right? So now, in this case, we can cancel out these factors, right? So the factors 2 to the power of x minus 1, 2 to the power of x minus 1 cancel out. And then what do we get? We get limit as x approaches infinity for 2 to the power of x. Now 2 to the power of x is an exponential function. As you know, its graph is kind of like this, right? So it is always increasing. And so it approaches infinity, right? So as it approaches infinity, and infinity is not a defined number, therefore we say it does not exist, right? So it does not exist. So there are a couple of ways to write this. Sometimes we prefer to write infinity, a positive infinity in fact, showing that it is going towards an unbound very high value, infinitely large. The other way is, as far as infinity is concerned, it is not approaching a fixed value, and therefore we write that it does not exist. So both are the right solutions, correct? But I want to make it clear, since at times students get confused whether the answer should be written as infinity symbol or does not exist. Well, this also means it is approaching infinity, but that is more explicit, right? So we know exactly why it does not exist, right? So that is preferred at times, okay? But since infinity is not a defined value, we say that the limit does not exist, right? I hope now it is clear. Now again, let me explain you how did I factor that. What is the meaning of 2 to the power of 2x? Let me write this clearly. 2 to the power of 2x basically is 2 to the power of x times 2 to the power of x. So when you multiply with the same base, you add the exponents. X plus x is 2x, correct? So when I factored one of them out, and I was left with 2 to the power of x, correct? So I hope that helps you to understand this point also. Now let's look into the next question. Now in this, we can apply the properties of limits, and we can say, well, this could be written as limit as x approaches infinity for 2 to the power of x minus 1 minus limit as x approaches infinity for 3, right? Now 3 is a constant, so that is going to be 3 on this side. If x is very, very large, something divided by a large thing should be 0. So we get 0 here, minus 3, right? So what do we get? We get minus 3 as our answer. So here the limit exists, and the limit is equals to 3, right? So this limit is 3, and this is not defined, right? So that is how you can actually find limits at infinity. So there could be many questions where the limit does not exist when x is approaching infinity. However, you'll see many examples where it does exist, and normally we call this also as a horizontal asymptote. Okay, so at some places the question could be determine the horizontal asymptote. In that case, they are indirectly telling you to find limit as x approaches infinity, right? So that is another way of looking at it. That means the function is approaching a value of minus 3, but it is not quite there, and therefore we say it's approaching, and it's a horizontal asymptote. Okay, so that is how it is. I hope that helps. Thank you and all the best.